Welcome back to my channel Kishore Sir Ki Pathshala. We were doing structure of the atoms 9 Cbse. Last time we did noble elements and valency. We have seen the noble elements, they do not react with any of other elements as their octet is fulfilled. So today we are going to see concepts called as atomic number. Now what is atomic number all about? So we are aware that protons are present in the nucleus. If you see inside an atom, you'll see a nucleus is there and you'll see the discrete orbits are there. So here is the nucleus. So nucleus, you'll see that there are protons inside, right? So it is the number of protons of an atom which determines its atomic number. So it determines its atomic number. So number of proton determines its atomic number. It is denoted by Z, by letter Z. All atoms of an element have the same atomic number. In fact, elements are defined by the number of protons they possess. So number of protons if an element is having, so it is denoted by that number of protons, right? So for hydrogen, if you see, number of proton is 1. Okay. Only one proton is present in this nucleus of hydrogen. For example, if you see carbon, 6 protons are there. Therefore, atomic number of carbon is 6. For oxygen, it will be 8. Right. So, atomic number of oxygen is 8. Likewise, all other atoms have been denoted atomic number based on the protons. And we also know that number of protons is equals to that of number of electrons. Now let's talk about atomic mass number. What is atomic mass number? Now if you see, the mass of an atom is practically due to the protons and neutrons alone, right? If you see in the nucleus, suppose this is the nucleus and in that I have got proton and I have got neutron in that, right? So, and also in the orbit, I have electrons here, right? So, if you see that the mass of the atom is practically due to what, protons and neutrons alone, because electron is having a negligible mass. So these are present in the nucleus of an atom, that proton and neutron. So therefore you will see that protons and neutrons are also called as what? These are called as nucleons, right? These are called as nucleons. And the mass of an atom resides in the nucleus. Okay, as electron is having a negligible mass. So the total mass of the atom is nothing but it is the sum of mass of proton and neutron. For example, if you see in carbon, right, there are 6 proton and 6 neutron are there. So what it will be, 6 plus 6, right, 6 atomic mass unit, 6 atomic mass units. So what will be the mass is 12 atomic mass units. Okay. So similarly, if you see the mass of aluminium is 27. Why? Because there are 13 protons and 14 neutrons in aluminium. So we can define the mass number is defined as the sum of total mass of protons and neutrons present in the nucleus of an atom. So this is the definition for mass number, and it is denoted by capital A, right? So for any of the elements, suppose if we take element as X, right? So how it is denoted? It is denoted by this mass number, that is A, and atomic number Z. That's how we need to write down. So for example, if you take carbon here, right? Okay, so mass number of carbon will be 12 and atomic number is 6. Right. So symbol of the element C we have written, mass number 12 we have written, and atomic number 6 we have written here down. Now let's talk about isotopes. Isotopes are defined as the atoms of the same elements having the same atomic number but different mass number. So you'll see that it will be the same element, right? But it will have what different mass number having the same atomic number. Let's see example of hydrogen atom in that case. It has what? It has 3 atomic species, right? So you'll see that protium is there. Protium, that is my 1, right? So you'll see that atomic number is 1 here and atomic mass is 1. Okay. So then you see deuterium is there. In the case of deuterium, what you see is that in case of deuterium, it is atomic mass is 2, atomic number remains constant, right? And in case of tritium, it is what? It is atomic mass is 3 and atomic number remains the same. That's 1 is same across, right? Here you see that atomic number of each one is same, that is 1. But the atomic mass number is 1, 2 and 3 respectively. Okay. Now if you see an example of carbon which has got 2 isotopes, here it is what? See, atomic mass is 12 and atomic number is 6. In other case, it is 14 and 6. Here you will see that atomic number remains constant and its atomic mass is different, right? But the elements is the same. So that's the isotope all about. Many elements consist of mixture of isotopes, right? So what will happen is that the element will be there and it will consist of what? Mixture of isotopes in it, right? So each isotope of element is a pure substance in that. Alright, so we are going to see the example for that. The chemical properties of isotopes are similar, but their physical properties are different. So chemical properties will be same, the physical properties will be different in that case. Now if you take the example of chlorine, right? Chlorine, you will see that okay, it occurs in nature as a 2 isotopes, okay, which has the masses of 35 and 37 in the ratio of 3 to 1. Now here the question arises, what should we take as the mass of the chlorine atom, right? So the average atomic mass of chlorine atom on the basis of above data will be, here you will see that I have got chlorine which has got 35 and 17 and 35 and 37 and 17. You will see that it will be in a mixture, right? So some proportion of chlorine and chlorine 35 and 37 will be there. So we know that it is in the ratio of what? 3 to 1, which is present. So now what we need to do in that case? So how we need to calculate? So here you will see that what we have taken the sum of those in the ratio of 3 to 1. Alright. So here we have taken as, you will see that 75 upon 100, that is my 3, and this is my 25 upon 100, that is my 1. And we have taken the ratios and we have sum it up, and that is we got 35.5 atomic mass unit, right? So this does not mean that any one of the atom of chlorine has a fraction mass of 35.5, right? So it does not mean that it is having 35.5. It means that if you take a certain amount of chlorine, it will contain both the isotopes, that is it will be 35 and 37 in that. It will contain both the isotopes of chlorine and the average mass that is the average mass will be 35.5 atomic mass unit. Now let's remember that the mass of an atom of any natural element is taken as the average mass of all naturally occurring atoms of that element, right? So here you see that it will be nothing but like this. Okay, if an element has no isotopes, then the mass of its atom would be the same as the sum of the protons and neutrons in it. But if an atom occurs in the isotopic form, we have to know that the percentage of each isotopic form, and then we need to average it out, right? So that's how the mass is calculated. Now let's see its applications, the uses. So some of the isotopes have special properties which find them useful in various fields, like an isotope of uranium. It is used as a fuel in nuclear reactors. An isotope of cobalt is used in the treatment of a deadly disease, that's cancer. An isotope of iodine is used to treatment of goiter. Now let's understand what we mean by isobars. Isobars are atoms of different elements with different atomic number, which have the same mass number, are known as isobars. Here you will see the number of protons in these elements will be different, but their atomic mass will be same. Now let's consider two examples, that is calcium and argon. So you'll see the atomic number of calcium is 20, means that the number of proton is 20 in calcium. For argon, the atomic number is 18. So the number of proton is 18. So we see here that the number of proton in these atoms are different, right? But if you see the mass number is 40. Okay, so the mass number for both these elements is 40, right? So the total number, what you see is that total number of nucleons is the same in the atoms of these pair of elements, right? Why? Because the number of neutrons will be different in that case in both the elements, but the sum what you get is 40 in each case. So the total number of nucleons will be same for calcium and argon. So that's my isobar is all about. Thanks for watching my channel Kishore Sir Ki Pathshala. Keep watching for more informative videos. Kindly like, share and subscribe Kishore Sir Ki Pathshala.